In this video, we're going to be looking at derivatives of trigonometric functions, as well as looking at some mixed problems, and then briefly looking at the absolute value function. So firstly, derivatives of trigonometric functions. So we're going to be looking at trigonometric functions such as sine, cos, and tan, and what do these derivatives equal? And the main thing with this is you basically have to memorize what the base form is. So what's the derivative of sine x? Then you can use a chain rule to work out other questions such as sine x squared plus 4, for example. However, with the basic sine, cos, and tan, it's just easiest to memorize what their derivatives are. So what is the derivative of fx is equal to sine x? So f dash x, or y equals sine x and dy dx, is equal to cos x. So it swaps from sine and it changes to cos. So what about cos x then? Well, if fx is equal to cos x, then f dash x, or dy dx, is equal to negative sine x. So the same thing happens, it swaps. So you can remember that with sine and cos, when you differentiate it, or you find the derivative, the sine swaps the cos and the cos swaps the sine. But there's a big difference between these two, and that's the negative sign here. So you have to be really careful of this negative sign. So when you're going from fx is equal to sine x to cos x, then it remains positive. Or if it's negative, then it would remain negative. So nothing changes. But if you start at cos x, so fx is equal to cos x, then you go to sine, then you're basically effectively timesing it by negative 1. So it becomes negative. If it was negative, so if you had fx is equal to negative cos x, then dy dx would equal sine x. So it has to swap from cos to sine, and because you've got negative sine x, because on negative, two negatives make a positive, so that would equal sine x. So what about tan? So if you had fx is equal to tan x, then dy dx, or f dash x, is equal to 1 over cos squared x. And this is equal to sec squared x. And so sec x is equal to 1 over cos x. So that's just another way of writing it. So the derivative of tan x is equal to 1 over cos squared x. And you can actually prove this by realizing that tan is equal to sine x on cos x. And then you can apply the quotient rule, so letting u equal sine x and then v equals cos x. And you can apply that and you'll find that the top is going to equal 1, and then the bottom is divided by v squared. And so v is equal to cos x. And so that's a good way to practice the quotient rule, to see that tan x gives the answer of 1 over cos squared x. So we'll do a few examples here. So fx is equal to 3 cos 2x. So what does f dash x equal? Or what does dy dx equal? So here you can go let u equal 2x. Now once you get used to it, you don't have to do this entire step for easier questions like this, as in the middle term is 2x, which you can differentiate it relatively quickly. When I mean easier, it's not like it has a large polynomial in the middle. So you have 3 cos 2x. So we let u equal 2x, and we get dy, or y is equal to 3 cos u. Then dy du is equal to 3 sine u, because remember cos and sine swap. Then you have to put a negative sign because we started at cos. So 3 cos u, and it changes to negative 3 sine u. So then if we want dy dx, that is equal to dy over du times du over dx. So what does du over dx equal? Well, that's the derivative of 2x, so that is just equal to 2. So there we're going to get dy on dx is equal to negative 3 sine u times 2, which will give us negative 6 sine 2x. So the important features of this question. Firstly, it's going to go from cos to sine. A negative does go out the front. Then we've times it by the derivative or whatever's inside here. And the derivative has remained the same. So we differentiate it, and just like when we have e to the 2x will remain the same. So it's like cos and sine. Whatever's in the middle term with the derivative will still remain there at the end. So another question. If fx is equal to 3 sine x squared minus 3x, what does f dash 2 equal? So the first step is we need to work out what the derivative equals. So f dash x is equal to 3 cos x squared minus 3x. So I've just swapped sine and cos, and there's no negative because you started at sine. And then you need to times by the derivative of whatever's in the middle. So it's going to be 2x minus 3. So the answer is 3 2x minus 3 cos x squared minus 3x. So it's quite a beefy answer. Then we have to sub in 2, and we get 3 4 minus 3 cos 4 minus 6. That is equal to 3 times 1, so 3 cos negative 2. And you wouldn't, if it was by hand, normally you'd get a nice answer, such as, example, 3 cos pi on 4, which you could calculate. However, it's the same steps, you just go through here, but normally there may be a pi in there to make the answer nice, especially if you're doing it by hand. But otherwise, you just leave it in this form, as that's the simplest you can go without a calculator. So what about now moving on to some mixed problems? So these are some functions. So how would you differentiate them? So this is just to go through some of the techniques we've done in previous videos. So x squared plus 4x minus 2. Well, what we do then is, because they're being all added or subtracted, we can just differentiate each one. We can do that by recognition in regards to x squared goes to 2x, plus 4x goes to plus 4, because we bring the 2 down, 2 minus 1 is 1, x is 1, 1 minus 1 is 0, so we get 4 times 1, and minus 2, that's just a constant, so plus 0. So what about log ex and sin x? Well, to do that, we have to use the quotient rule. And that's because it's 1 divided by another, and we can't simplify it. So that's when we let u equal log ex, and v equals sin x, and we look at the formula there, and you apply that formula. So what about this one? X squared minus 4x to the power of 3. Well, we could expand it out, but that's going to take a long time. So the easiest one for this is we can put in the form u to the 3, and then bring it down to 3u squared, and then using the chain rule, we can calculate it. So here, we wanted to use the chain rule. So what about this? How do we calculate x squared times e to the 2x minus 3? We know how to calculate e to the 2x minus 3. We know how to calculate x squared. Because they're being multiplied, we have to use the product rule. So once again, you look at the formula, work out that u is equal to x squared, v is equal to e to the 2x minus 3, calculate the derivatives, and then sub it in. So finally in this video, I wanted to look at the absolute value function. So I've briefly mentioned this before, but when we calculate the derivative of the absolute value function, you want to put it in hybrid form. So let's say that's the function. It's a modulus x cubed. So if we wanted to graph it, we'd graph it something like that, and then we come down, then we'll bring it back up again. However, we want to calculate derivatives. So if we put this into hybrid form, so this is just the function at the moment, this would equal x cubed when x is greater or equal to 0, and negative x cubed when x is less than 0. So if we differentiate it, we can differentiate and put into this hybrid form. So this would equal 3x squared, and then negative 3x squared. So we just differentiate both rules, and then we can put it like that. The domains stay the same, however, you don't have the equals to sign. And the reason for this is because of the moduluses. When we're talking about what can you differentiate it, it had to be smooth. And these points are sharp points. For example, if you had y is equal to modulus x, if you remember, normally it would go all the way down, but because of the modulus, it goes like that. And that point there we call the sharp point, which you cannot differentiate. So the really key feature here is to put in the hybrid function, differentiate both the functions as normal, but remember the equal sign doesn't carry over to the derivative, and at that point, when x equals 0, the derivative doesn't exist.